Ladies and gentlemen, boys and girls, thanks for tuning in. I wanted to make a quick video to talk about all the questions and comments that I got on a talk that I gave a couple weeks ago in Barcelona at WASM.io. The recording of it just got published a couple weeks ago, and there's been a lot of people that have watched it, and there have been a lot of people who commented on it. So instead of jumping into each comment specifically, I thought I could do better by sort of getting into each one on a video so that I can give a more in-depth answer across the board. So with that being said, let's just jump right in. So let's see. First comment's mine. Let's see. Lou Hot says, "Wow, before virtualization started, a Windows Server image on VMware was about 40 gigabytes. Box is 1.8 megabytes. That's 22,000 times smaller. Some CPUs have 480 megabytes of level 3 cache. You could run 240 processes and keep all of them in L3 cache on the CPU. LOL. Great job." I thought Alpine at around 128 megabytes, if I remember correctly. And they say, yeah, Alpine is 3.46 megabytes. Yep, cool. So the example that I gave in the talk is with no optimization. So if you're familiar with WASM opt, no WASM opt, like no sort of shaking of unused code. It also brings in every single interface and source code that we have available in Marcotte. So to actually run that code in Boxer, it would be considerably smaller. But yeah, that's kind of the general appeal, is that it can be much smaller and the sort of execution environment is dramatically different. So yeah, thanks for the comment. Let's see, super interesting super interesting project. Most devs are comfortable with Docker ideas, but WASM is still a little bit out there. Great translating and mapping from D to W. Yeah, let's see. Okay, cool. Is it? I mean, it's just another binary format for code that you run with a virtual machine runtime of some sort that is designed to allow each binary to be sandboxed, similar to Java.NET bytecode. It's all stuff we've seen elsewhere in some form or another. Yes, there is always a comparison drawn between the JVM and WebAssembly. My colleague and the co-founder of Loophole Labs, the founder of Loophole Labs and CEO, Shiv, gave an excellent talk at Devox last year, 2 years ago, about the fundamental differences between the JVM and the WebAssembly VM. I highly suggest you check that out. I'll link it in the comments too. But yes, so the goal between the JVM and with WebAssembly is roughly the same. In fact, some of the people that started WebAssembly worked a lot on the JVM, and there are some fundamental differences in approach. But there's a lot of details there. One of the main ones is that there's nothing related to any sort of language runtime that is assumed in WebAssembly, which is not the case with the JVM. Though the JVM has evolved and changed, there's quite a different runtime with the Graal VM, which has taken a lot of the things with the JVM and made it a little bit more abstract and usable with other languages. I highly suggest you check out Graal VM, really cool stuff they're doing. But the sort of the devil's in the details when it comes to the differences between the JVM and WebAssembly. And at the end of the day, the bottom line is that WebAssembly is meant to be more universal, not tied to a specific language runtime, and without a lot of assumptions that the JVM baked in around Java. That in and of itself is a huge and long talk and discussion. But I'll link the project that I'll link the talk rather that I am talking about. That can give you some more detail. Let's see. Sekat, yes and no. Yes, in the sense of using both code, but different in every other sense. DSL, generalized, massive language-specific runtime and management. Yeah, exactly what I was just saying. Bare basic compute and linking, OS abstraction and integrated systems, bare basic compute and stack memory, proprietary and fragmented specification, open source standard universal target, hard to support, easiest to interpret bytecode by far. Yes, so that covers and touches on many of the points between the differences, but there are some large differences. Though the goal maybe is largely the same, it just maybe the details might change the effect that it has in terms of adoption and use. So yeah, interesting discussion. Battery Acid 1103 says, so to massively oversimplify, Boxer is essentially WASM script in plus WASM time or some other native runtime packaged together, and it can also read Docker files and has an isolated virtual FS. Is that roughly correct? That is correct in terms of the high-level points, with a couple key details that are different. Specifically, Boxer does not use WASI or Mscripton. Boxer uses its own tooling for implementing the host functionality and the virtualized host functionality, specifically platform functionality, with a project called Marcotte, which I mentioned in the talk. It's not public right now because I need to clean it up. But basically, Marcotte fills the sort of space that in a project like this, WASI and Mscripton would occupy. And what this means is that we take system functionality and we are generating it and virtualizing it so that it can be WASM first, so that it's virtualized first. There's a long discussion there about what WASI and Mscripton's goals are and how they work with this, but everything else there is generally true. When you say it can read Docker files, it has a an isolated virtual FS, there is an isolated virtual file system, and it reads Docker files, but part of that reading of Docker files tries to sort of build up the module in a sort of stepwise fashion, similar to how Docker does things with layering. There's a lot that goes into that, but the goal of Boxer is to sort of have these build steps that can be reproducible and that you can get the same artifact and have different stages of that artifact. Let's see. A reply here. Honestly, I don't know what this solves exactly. It seems like born out of the concept. We don't have time to wait for WASI to become a thing, so we hack our way around to deliver something similar. I'd rather wait for WASI to become viable and standard. Okay, yes. Good point in terms of certain assumptions that we can make about WASI. WASI is an incredible project that a lot of really, really smart people have been working on for years. The one thing I will say is that if you've been involved in the community or paid attention to the developments, WASI's goal is not to have complete POSIX compliance. WASI has sort of evolved when we had Preview 1 that supported certain POSIX things, and then Preview 2 introduced the component model, which sort of shifted their focus towards standardizing interfaces. In fact, they thought about changing the name to WebAssembly Standard Interfaces instead of the WebAssembly System Interface, because it's a more fitting description of the project. WASI will not support platform native code out of the box by default when it's fully standardized. That's been a discussion that a lot of people have had. There's been reactions to that. But if you look on the WASI README on GitHub, you'll see that it says that exact same thing, right? So when WebAssembly native means the platform isn't directly compatible with existing applications, but for other platforms, it's designed to enable compatibility to be provided by tools and libraries, right? So in the talk, I also mentioned that this is not at odds with WASI. What Boxer does is not sort of in opposition to it. In fact, it's just a different level of abstraction. So there's no reason that you can't have both capability-based security, which is a huge design goal of WASI, in addition to POSIX compliance maybe on top of that, or in relation to it, or choosing certain things that you want with different implementations. Yes, this is something that gives you more native compliance, but WASI in the end will not give that to you out of the box, which is fine because their goals are different. The other thing too is that saying we don't have time to wait for WASI, so we hack our way around to deliver something similar. The difference with what Boxer is trying to do via Marcotte is to provide mostly POSIX compliance with a different implementation. So the difference there is that POSIX is actually well defined already with a spec, and you can run test suites against it. So we can show and prove that Marcotte can generate POSIX compliance literally by running things like the glibc or the muscle test suite against it. We haven't done that yet, but that's something that we would like to do in the future. So let's see. Ephemere. says, I don't get it. It's not at all the same DX as Docker because the challenging step here is compiling to WASM. Boxer doesn't appear to help with that step at all. Once you have a WASM binary, you can just run it with a WASM runtime, which you can do already. WASM provides a POSIX environment. How is this any better than what we can do today? So WASM can already provide a POSIX environment. I just addressed that on the previous comment. That is not completely true and won't be true in the future, so that's fine. Let's see. It doesn't address the compile step. That's true. Although in the talk itself, I did mention that I skipped over a specific step, which is the box compile step. And that means that when you have a C program and you need to compile it against what is our version of a libc and system functionality, you need to compile it using box compile. And one of the big goals, which I also mentioned in the talk, is that we'd like to make it easier to compile things to WebAssembly. If you try to do things like compile stuff to WebAssembly, compile native code, compile code that you've written for other projects, you'll notice very quickly that you run into a lot of problems. One of the goals of Marcotte is to fix those problems by making it easier so that you can compile things like you would on native. So the compile step is actually one of the major goals, and it is addressed. I just didn't focus on it specifically in the talk. That's also something that Marcotte handles by generating the system layer functionality and making that easier to compile right now, C and C++ programs into WebAssembly. So, good question though. Dude, this is nuts. Thank you. Thanks very much. We already have the unikernel dream. I'm not sure if that means like, why are you doing this? Because we already have the unikernel dream, or like this brings the unikernel dream. But yeah, like unikernels are a similar thing to this in terms of selected functionality that's very specific to the source that you're trying to run, and something that is very tightly controlled and is better for security, all these things. This, you can kind of think of Boxer as sort of bringing a lot of ideas from unikernels in kind of a weird way to a new execution paradigm, which is WebAssembly. And that opens up a lot of interesting possibilities. So yes, we do have the unikernel dream, and there's more to talk about there. Rish Kumar, ZO2HC. I think that Zig could be used as a final solution here. You get a thin C++, and WASM compiler, and you get all Clang APIs there as well, and it's fast. Maybe something can be done here to make the new way to make code for the future and applications for the future. Okay. Okay. Yeah, I mean, Zig is interesting. I'm not super familiar with the Zig community and the Zig ecosystem, but there's a lot of interesting stuff about how you can use C compilers with Zig. I think that the step of building system functionality that will work in a WASM native environment is still something that wouldn't be handled in that case, but it's definitely something to explore. How does this differ from Docker built-in WASM workloads published in 2022? Yeah, so so if I'm familiar with this, right. So WASM workloads in Docker are an interesting thing. It's basically a Docker container, from what I understand, that wraps different runtimes. Yep, here we are. Different runtimes in the actual container itself, and then you can execute WASM in that runtime within the container. So that's interesting and cool, except this means you don't need the container at all, right? So like you don't need the container, you don't need the container runtime, you don't need the container runtime interface, you don't need the storage interface, you don't need the networking interface, you don't need a Linux kernel, you don't need all these things, whatever interfaces outside of that. So it differs in the fact that it takes a lot of stuff away, and the WebAssembly artifact is the result of what you build from the Dockerfile definition. So that means like we're basically using like a similar interface, a similar experience that you would use with Docker, that you would use with containers, but the end result is something that doesn't need any of the machinery of containers at all. In fact, it takes the different approach where it's like instead of relying on the underlying operating system, you are building in that functionality and then making it available to your source program. So it's quite a bit different in the end results. I can see that it's still kind of confusing because this is like such a different paradigm. But basically, like instead of running WASM inside of a container, you are just running WASM, and you're doing this in across heterogeneous environments. And it's something that kind of opens up different doors to how systems can be built. Jimmy Media 2049 says, any plans to have a WASM image hub similar to Docker, and what would be the best approach to running these on cloud, AWS, for example? Yeah, great question. Yeah, I mean, let's see, a WASM image hub similar to Docker. I don't personally have any plans for that. I think that there's no reason that we can't leverage OCI and have OCI compliant registries. People are already familiar with that format, and there's no reason you can't apply the same format to something like Boxer. And let's see, what would be the best approach to running these on cloud? Yeah, I mean, right now, the best approach is to have a bare bones VM that has a WebAssembly runtime on it. If it's WASM time, WAS0, etc. Right now, we bundle WASM time, but you can literally just have a VM, download the binary, and run it. And if you can run the WebAssembly runtime on that VM, then it can be executed. In the future, it would be cool to have sort of an optimized image, or even like bare metal, where you wouldn't need an entire distro, and you should be able to have the entire base functionality of what you built using Boxer available to you. So yeah, we're not really quite there yet, since this is still under a lot of sort of experimental developments. But the idea is that you can run this stuff anywhere, right? So more to come on that for sure. Let's see, LOL at Dockerfile being beautiful prior art. I mean, that's fair. Yeah, I totally get that. I think my point there is that Docker files are ubiquitous, and they're so common now that people can read them and understand what is going to be built and use them. And prior to Docker, there was nothing like that for building containers, though containers had existed in Linux for a while. So. The objective of Boxer, which should really be explained first, is only mentioned after 18 minutes. Yeah, sorry about that. If you go to Boxer.dev, there's a TLDR right here that kind of gives you the TLDR. So, yeah. Is this available somewhere that I can use, says Imasen 4 days ago. Yeah, right now it's like a pre-alpha release, so you can download the code. There are bugs, and I'm still working on making sure that everything's available. So yeah, the answer is no right now, but it's a pre-alpha project. I'm going to be doing more releases. If you're interested, check out the waitlist. You can give us your email, and we'll email you as soon as the sort of alpha release is ready. Rabbit V321 says, so you want to create a more lightweight embedded like kernel container, a container D, I'm guessing, embedded? If I understand that question correctly, the answer is yes, kind of. There's no reason that you won't be able to run stuff that is generated with Boxer, besides things like resource constraints, on embedded environments. So that's also a really interesting area that I'd like to explore. Yeah, the idea is that like you can run this stuff in very resource constrained places, and you can have everything that you would, or most of the things that you would, to execute your program that is provided to you by an OS. There's a lot there. Some people are doing some really interesting work in the embedded space with WebAssembly. And yeah, I mean, that's on the table. That's probably a little far in the future, but definitely something worth exploring. Chris Weber says, does this solution give a happier path for including databases into the mix? Achieving the goal of running 95% of container workloads would likely mean being able to MySQL into a WASM container. Yeah, well, just like there's no reason that you can't use MySQL in a container today, there will be no reason that you can't use MySQL in a Boxer box, in a Boxer generated artifact. A lot of people maybe don't like use databases and containers for a lot of things. They use volumes. That's another thing to approach down the road. I think that the interesting thing here is that, I mean, this kind of highlights a point that, yeah, I mean, any user space program like MySQL will be able to run in Boxer or with a Boxer generated artifact. What that means for data persistence and what that means for sort of underlying file systems and underlying like block devices, maybe that where things can be persisted across ephemeral runs is something that there's a lot of options to explore there. But yeah, absolutely, you can definitely run a database in a Boxer generated artifact, certainly. Antonio says pure gold. Oh, thanks. Let's see. Jarhead Crayon Eater says, this is my kind of out-of-the-box thinking I've used for my entire career. Pun intended. Excellent pun. Thank you very much. Yeah, okay. Denise says, does it work for binaries with statically linked libc? Does it work for Golang, which doesn't depend on libc? That is an excellent question. First question, does it work for binaries with statically linked libc? No. I mean, if I've already compiled a libc and that's in your resulting code and was compiled for a different platform, then no, it won't work. You need to compile it against Marcotte, which acts as the libc in this sense, but as also the system itself. And then from there, like that is your statically linked libc. Does it work for Golang? So yeah, Golang doesn't use libc. There's cgo, which is kind of a mess. Yeah, so with things, so with Marcotte and Boxer specifically, we started with C interfaces because that covers like a large tract of programming language functionality. But does it work for Golang? So Golang is something where we need to figure out how we can compile Golang to this, and there's a couple options. Like you can use GCC, which will expect a native libc. You can use that. It brings in C dependencies. But then the other thing is that this is going to be a problem with other languages that don't use libcs. But what Golang does use is Golang uses raw syscalls. So the layer right below that is also what's generated with Boxer and Marcotte. So this sort of translation layer from calling raw syscalls on this new environment is still, that work is still being done. It's just without C interfaces. So with the way that I kind of foresee this going forward with Golang is that we provide specific shims for Golang, which you need to write once, which then work for all syscalls that Golang calls, right? And that is sort of a next step, but that is more work for sure. But theoretically, that is definitely something that can be handled. 6 Diego 1 Diego 9 says, I don't get it. Okay, well, that's fair. Happy to talk more. Oh, cool. Serge said, virtualization layer that works anywhere, specifically on web client, opens possibilities for running a system components on a client, having fat clients. Yeah, that's definitely part of it. Let's see. Sir, what are you getting at? Let's see. It's a cool little side project, but this feels highly specific solution. It's a highly specific solution that a problem that Daniel might have had with containerization rather than a real alternative to it. Maybe WASM boxes can be faster, but speed alone is not a great selling point. Maybe I'm a bit too skeptical, but I will give it a shot when it drops. Maybe I don't get it from this intro because it's a little half an hour with some Q&A in there. Yep. I mean, there's a lot to it. One of the more interesting things I think about this project is that it allows you to run things in more places. And you can take the same definitions and run them anywhere. Like, for example, if you could have in your browser the container that you're working on for your CI or that you're working on for your dev environments, and you could run that in your browser, and then you could maybe have that and run it exactly the same way locally, and then you could push that exact same code and run that on the cloud. Then you would have 3 environments where you're literally running the same code, and you can do this in different scenarios, but in ways that can be supported across all these different environments. So Yeah. Basically, like the goal is simple: is to take containerized workloads and run them in these new ways, right? So maybe that'll become clear as we get more work done on it. Fontainebleau says, never heard about this. It showed in recommendation only today. Considering Docker's main obstacle, it could take most or all storage to get. Set just one AI project, usually highly unpractical. Okay, I'm not quite sure what is being said there, but basically, if we're talking about AI, one of the interesting things is that there's no reason that this can't be used for Python workloads and workloads that leverage a lot of the AI libraries that Python uses for machine learning. Cool. In the last few comments, yeah, I'm just gonna leave those for now. Okay, yeah. So thanks again for all the great comments and questions on this video. There's a lot of work to be done on this project. Releases will be coming soon. They will be incremental for sure. But I really would love to keep talking about this. And if you're interested to learn more, check out the subscribe button here. You can submit your email and we'll send you the earliest and most available updates as they come out. So yeah, thanks again.